Recent leaks and rumors have suggested that the high-end graphics card for the next-gen Radeon products has been cancelled, so no 8900 XTX for you. That's based on the fact that apparently there will only be N43 and N44 dies. But what if those are actually enough to make a high-end GPU? A recent AMD patent shows how an 8900 XTX could still be a reality. Let's dive in.
This video is sponsored by Urcdkeys.com. If you buy a retail Windows 10 key, you could spend $100 or more. But if you buy an OEM key from Urcdkeys.com, a Windows 10 Pro key will cost you only $15 when you use the coupon code C25. The keys work globally, and you can even get a free upgrade to Windows 11 from Microsoft. After you've made your purchase, you will find your key in your purchased orders in the Urcdkeys website. Click on Get Keys and copy the key. Then in Windows, click on Start and type Activate, and then click Activation Settings. Then click Change Product Key, paste your key you just purchased, and click Next. Your copy of Windows is now activated. If you want Office 2021 Professional, you can use the same C25 discount code and get it for just $65. Urcdkeys is running a mid-year sale with some cool mechanical keyboards, gaming mice, and even gaming chairs. A big thanks to Urcdkeys.com for sponsoring today's video. Check the links in the description to get your cheap OEM Windows keys today.
This patent that has just been published shows a chiplet-based GPU that divides draw calls work through the multiple chiplets in a GPU using an indexing system. The way this works is the first graphics engine in a chiplet receives an indication of a draw call and an address and size of the index buffer that corresponds to the graphics object. So if there's a draw call for a triangle, the system sends an indication to the graphics engine in that GPU chiplet, and along with that, also sends the address and the size of the index buffer for that triangle. The geometry engine then calculates locally in the chiplet which portion of the index buffer to fetch. It then fetches the portion from memory, but note that the following fetches are non-contiguous, so that means they don't have to be done in order. They are done in parallel by the multiple graphics engines. You can think of it as the graphics object being divided into many portions, each portion having an ID which is stored in an index, and then each graphics engine fetches a portion and works on it, all of them working in parallel. And in the end, the resulting calculations, which are pixel data, are stored in a table. This scales to how many geometry engines there are. So if a GPU has 4 chiplets and each chiplet has 2 geometry engines, then there's a thread of 8 geometry engines working all at the same time to process an object. AMD makes sure to mention in this patent that there is no centralized controller that orchestrates this, so this is different from AMD's other patents on chiplets and from Intel's patents. Once all this is done, the tessellator engines process the final patches. Once the system knows how many patches should be allocated to each tessellator, let's say 6, the tessellator with the logical ID of 0 would process patches 0 to 5, then tessellator with ID 2 would process patches 6 till 11, and so on. So basically the pixel data for an object is rendered in parallel with each chiplet addressing a portion of it. The bit of an image that you see in a game, all the pixels that compose it would be divided into small chunks and distributed to each graphics engine in each chiplet. This method has some similarities with Intel's patented tile rendering through chiplets, basically dividing the whole image into small tiles and having each chiplet handle a single tile sequentially, but done in parallel, kind of what we see in the Cinebench multi-thread test. I've covered that promising method in a past video if you're interested. AMD's is different in the sense that the division of work is more fine-grained. Instead of dividing the whole image into tiles, it divides each individual draw call. It's a different way to skin the same cat, but ultimately the same bottleneck is a concern for Intel and AMD, which is how quickly can the data be fetched from memory to the chiplet for processing, and how much energy will be spent in doing so. The further away it is, the longer it takes and the more energy is required, several orders of magnitude more in fact. So the solution would of course be having all this happen locally using on-chip memory. Would that be possible? We've already seen in AMD's RDNA 3 that AMD has decided to invest heavily in local memory, but with just one chiplet to do all the work. The path forward, if this patent is any indication, would be to have multiple chiplets access a shared pool of local memory. This hints at a package with a large number of chiplets, both logic and memory. This comes at a time when Twitter leakers Alderwatts and Kepler have indicated there will only be an RV43 and Navi 44 SKUs, suggesting that no high-end SKU, so that would be Navi 41 and 42, will be launching to compete with Nvidia's 5000 series. I find that hard to believe, honestly. Kepler in particular has a terrible track record, and even if these two leakers are correct, the AMD patents on chiplets could mean that you don't need a Navi 42 or 41, but AMD could instead use a smaller die in multiples in a single package. So the high-end Radeon 8000s would have several of the Navi 43 logic dies instead of a single large Navi 41 chiplet. In this same patent, we get a hint of how messaging between the chiplets would work. Message passing between chiplets would require a check for the location of a reset index on each chiplet. In other words, when the message is sent, it includes whether or not the chiplet sending the message has reached the end of the index, and therefore if it's time to go fetch another index. This would imply that the chiplets need to be physically adjacent for this to be viable. I've covered in the past how data transfer could work from active interposers to silicon bridges. I've done several videos on that. In this figure, we can see that to keep the chiplets in synchronization, the rasterizer issues a state ID for each corresponding pipeline. In this example, the chiplet has two pipelines, but that's just for illustrative purposes, as there could be many pipelines per chiplet. Another possible implementation would be to have hull shaders that have full geometry shapes, and then there's a granular distribution of the work that needs to be done to that shape within each chiplet. This implementation would result in less memory or bandwidth being required. So what would this GPU look like? So let's say AMD just shrinks Navi 32 and calls it Navi 43, and 32 has a GDC size of 200mm squared, while the MDCs are 36.6mm square each. Going by TSMC's projections for 3nm, we would get a reduction in size of 35%. So that's for the second generation of 3nm, or what they call enhanced N3. So this node has nothing to do with what Apple is using for their latest phones. So that would result in a 130mm squared die. Let's be conservative and say the shrink on the MDCs would be merely 20%. So that would be roughly 29mm squared. So we would end up with a package that would look like this. Based on these rough estimates, it ends up not being much larger than the current 7900 XTX package. And of course, with 3D stacking, you could make a much smaller package and the memory would be on top of the logic dies, the GCDs. Or alternatively, you could have this package and in addition to the MDCs, you could have stacked memory. That would help mitigate the latency, bandwidth, and energy consumption problems to a great extent. How likely is this? I think if AMD has managed to successfully get chiplet-to-chiplet communication working, as in with the GPU logic chiplets, I think it's highly likely, and it would be reasonable to expect evolution of the current configuration in the 7900 XTX and 7800 XT. And of course, as the patent states, this would be scalable, so we could see a version with 2 GCDs and a version with just one, and then perhaps N44 would be the laptop discrete chip. I think that's a reasonable guess based on this patent, but as we've seen in the past, not all patents end up materializing. Would this be enough to compete with Nvidia's next-gen top dog, the RTX 5090? Well, we will come back to that in an upcoming video and estimate performance for both, so subscribe to the channel so you don't miss that.